the 10-year series thing already? No? It's for you to fill out, not for desperation or notice board. Huh? Only Joseph buying the 10-year series. Come on, please fill it out by tomorrow, okay, so that I can go and place the orders. Some of you got your master results yesterday, right? How was it? Not within expectation. No. Then like that, how? What's the next step? Can continue to my master. Okay. Let's continue. 8.1. Equation of circle. Okay, so let's look at try 6. Alright, so we have another circle, the equation of a circle C1. Okay, whereby the radius is 8 units. And it has this equation here. And it says that P is more than 0. Part 1, we want to find the value of P. And coordinates of center C1. Okay. So what do you suggest we do? Factorize. Factorize, what do you mean by that? Compare?
Factorize first.
Factorize what? This one? What do you mean by factorize? Take out the 3. Okay, our aim over here is to determine the center of the circle, right? So to determine the center of the circle, we can derive it from the equation of a circle. Agree? Okay. So regardless of the form of the equation of the circle, so be it in the standard form or the general form, we have the ways, okay, to determine what is the center. So now that we are given something that is of the general form, okay, we will work with that, right? And in order to work with that, okay, we have learned that we will let the center be the coordinates A, B first. Okay, radius we already have it, 8 units, so that will be out of our concern. And then we have previously been working with the standard form, right? So standard form is x minus a bracket square plus y minus b bracket square equals to r square, and r is 8 units. Okay? Then after that, what's the next step? What do you expand it, right? So we expand it. And 8 squared is 64, so we can simplify that. Then we will rearrange the terms. Sorry, this is a y. And we shift the 64 over to the right hand side. Okay. So in order to do comparison, we got to ensure that the coefficients are actually the same in the first place. But there is one very glaring one that's surely not the same, which is the coefficient of x squared and y squared. So if you were to look at this and compare it with what we are given, okay, there is an extra 3 over here. So there are 2 ways that you can handle this situation, okay, whereby your coefficient of x squared and y squared is not 1. One way is that you divide throughout this whole equation by 3. Okay? And when you divide, you must divide every single term and number. Alright? Otherwise, you can multiply by 3 across everything over here. Okay? So up to your preference. So 64 times 3 would be, what is it now? 192. Okay, so when you multiply across by 3, it allows you to be able to do your comparison accurately. Okay, so now we compare it with the given equation. We find that negative 6a is 24. Negative 6b is equals to negative 6p, which may not be very helpful. And we also see that 3a squared plus 3b squared minus 192 equals to negative 117. Okay, so from the first one we see that a would be equals to negative 4, b is equals to p. Okay, we got to find out what is P first, or we can find out what B first before we find out what is the center. So substituting it into here. So P squared is equals to 27 divided by 3, that's 9. And we find that P is 3 or negative 3. We reject negative 3. But what's the reason for rejecting? Why should we reject negative 3 for P? Yes, Joseph? Katie, any idea? P is more than 0. Very good. Okay, so question gave that P is more than 0, so we reject. So because P is more than 0. Okay. So it's a different reasoning from our usual way of rejecting whenever we do something similar. Previously, we always reject the negative one because what we were looking for was the radius r. And radius is a length itself, so it got to be more than 0. In this case, P is just a constant, but the question gave a certain condition to that constant number. So based on that condition, we reject it. So now that we know P is 3, B will also be equals to 3. So therefore, center is at our negative 4, 3. Any questions? Yes, Vina. Okay, any question? Otherwise, let's move on to part 2. Okay, in part 2 it asks how would you determine whether a line passes through the center of C1. Okay, that would mean that given a certain circle, and now that we know that the center has the coordinates negative 4, 3. Okay, how will we know whether a line, let's say this one here, will it pass through that point or not? What is a way that we can determine this? Sorry? Sub in the center coordinates into? Okay, so Joseph suggests sub in the center coordinates, which is negative 4, 3 on into the line. Right? Why is it that will work? Why would that work? Yes? Oh, wait up, yes. Yes, okay, very good. So because if a point lies on the line, okay, the coordinates x and y must satisfy this equation x and y. Okay, if the point does not lie on the line, it will not satisfy the equation. Do you agree? Okay, so that's the whole idea that we want to use behind it. Okay, so don't need to think too complicated. Don't need to think about perpendicular bisector and all that. Right? So we focus on the fact that if it passes through the point, it must satisfy the equation. So therefore, we check at the point negative 4, 3, left hand side of 3x plus 2y would be this substitution. So negative 12 plus 6, you will get negative 6, which is actually the right hand side of the equation. Okay, so to explain, since negative 4, 3 satisfies the equation 3x plus 2y equals to negative 6, the line passes through the center. We have that there's another circle passing through the origin, same center as C1. Okay, so we want to find an equation of C2. Equation will always require center and radius. We know the center already because it says that it is same as C1, so that will be negative 4, 3. So our challenge is to determine the radius. What would the radius be? How to determine the radius? So what do you think? Find the length of from where to where? Center to center to 0, 0 origin. Okay, so we find the length of the radius, which is the center to the origin. So that will be 5 units. And therefore equation or circle is x minus x plus 4 squared plus y minus 3 squared equals to 5 squared 25. Okay. That's on page 202. We are given the equation of a line which is going to be a tangent to the circle with the center 3, -6, and it is a tangent to the circle at P. Okay, so whenever we are given a circle question, for most of the time you got to imagine how it actually looks like. Knowing how it looks like is very useful for us to know how to solve the question subsequently. Okay. So since you're talking about the circle, let's just draw a circle first. Center 3, -6. It doesn't matter if you want to draw the axis or not sometimes. Okay, most of the time the axis may not be that useful, right? Knowing to draw the exact location of it is not really the most essential thing to do. Okay, so just draw a circle center there, right? Then after that, we have this 3y minus 4x plus 5 equals 0. So it's a line. I don't need you to go and figure it out whether is it positive gradient, negative gradient. Just draw a line will do. Okay? If you really want to go and determine, you will know that this one is shift, constant also shift, so that you get a y equals mx plus c. So once you shift this one, it will surely have to be a positive gradient. Okay? So sometimes if you can see it fast enough, then by all means you can draw it accurately in that way lah. Otherwise, just draw a line. Okay, that is correct to the property, which in this case is a tangent. Okay, so this line here, point P. So tangent over here. Question wants us to find what is the coordinates of P. Okay. So now that we have the diagram, we want to figure out how to determine the coordinates of P. So let's try to recall a certain property that we learned in our E-Maths last year. Okay? What is a property that you know about tangents and related to circles? I will study E-Maths. Tangent, perpendicular to radius. Okay? So that's a very important one which will help us in this question. Okay? So whenever we have tangent, we think about tangent perpendicular to radius. So with this idea, we draw in the radius. Radius can be anywhere from the center to any part of the circle, right? But of course, we want something that is helpful. We draw it towards point P, which is also going to be radius and also perpendicular here. Okay? So other than focusing that this is a tangent, this is a radius, you can also recognize it as two lines. Okay, there are two lines up. Right? So these two lines, where do they intersect? Where do they intersect? Where do these two lines intersect? Hello? Point P, right? They intersect here, right? Okay? So because they intersect here, okay, if we want to find intersection of two lines, we can solve simultaneously. But before we can solve it simultaneously, we need more information, which is the equation of this line. Because I have the equation of this line, but I don't have the equation of this line. Not having the equation will not allow me to solve simultaneously. So the next step is to think how to find the equation of this radius here, or finding the equation of the center C to P, okay, of this line CP, right? So thinking about equation of a line, right? So we were talking about intersection of two lines. So this was our train of thoughts, intersection of two lines. Okay, and P. Then we need to be going backwards. So we need to find equation of CP. So the two lines were tangent and radius. So radius was my CP. Okay, so we need to find equation of CP. Then we need to ask ourselves, what is the equation and how to find equation? It is a straight line. So y equals mx plus c. We need to know the gradient. We need to know the y-intercept. Okay. Can we find the gradient? How do we find the gradient? By making use of the tangent. Because tangent, we can define out the gradient, then perpendicular one. So can find the gradient for this line. Okay? Intersection point, this constant C value, we don't really need to go and draw the line and then find intersection, right? So another helpful way to help us to find out what is this constant number is that as long as I have one point on that line, I can find out what is the value for C really. Right? So I actually only need gradient and at least 1 point. That's it. Okay, so gradient and 1 point. Okay. So whenever you're given any circle question, you got to break it down first. Draw the diagram. Okay. See whether it's that point that you want to find. Is it an intersection point of anything? Okay. If intersection, you need to find equation. If equation, how to find? Since it's a line, y equals mx plus c. Okay. And equation line just need to rely on gradient and 1 point. Right? So let's proceed with the working. Okay, so gradient. 3y minus 4x plus 5 equals to 0 is the tangent. Manipulate it. We need it to be y equals mx plus c in order to derive the gradient. So gradient of tangent is 4 over 3. And therefore gradient of CP would be, answer what would it be? Negative? Now 1 over 4, you sure? 1 over 4 over 3. Ah, okay. Sorry, didn't catch what you said. Okay, negative 1 and 4 over 3. Could we simplify that? We don't write fraction in the fraction, right? What would that be? You can press calculator, you know. Press calculator, don't need to challenge yourself. Okay. As long as everything numbers can press calculator. Don't worry. Manage to get it? Will actually be negative 3 over 4. In other words, I need you to be able to realize that whenever it's a perpendicular line, it is negative of the number, and you flip the fraction, and already. No need to think about 1 over something. Okay? So gradient of the radius will be negative 3/4. Since we already got 1 point, so we can find equation of Cp. So y minus away coordinates of the center, negative 6 equals to negative 3/4 x minus 3. So there will be y plus 6 equals to negative 3/4 x minus 3. What's the answer? Negative 3 and 3 over 4. Okay, so we got the equation of Cp. Okay, but that's not an endpoint because we want to find the intersection. We found the radius equation and we got a tangent equation, so solve simultaneously. Okay, then take this equation 1, equation 2. This is the equation of tangent, this is the equation of the radius. So solving it simultaneously, I'll continue it here. So x is negative 1, right? And then y would be negative 3. So therefore, P has the coordinates negative 1, negative 3. Okay. We want to find the equation of that circle. Since we already got the center, we need to find the radius. So what would the radius be? Emily, what do you think? Sorry? How do we determine the radius? Length of line segment. Okay, between which two points? Center and P. Alright. So we find the radius of the circle, which is the length of CP. So that would be 3 minus away plus 1 squared plus negative 6 plus 3 squared. I think that's 5. Yeah. Okay, so equation of circle. X minus away 3 squared plus y plus 6 squared equals 25, which is 5 squared. Okay, for try it, we want to find the equation of the tangent to circle, given the equation of the circle, at the point negative 3 and 5. Okay, so could you maybe draw a diagram, okay, that would correctly illustrate what the question is talking about? Okay, just try to illustrate this question now. Give you a bit, 30 seconds to do so. Most of you drew a fair enough diagram, right? So we should be looking at a circle, something like this. No information about circle. We don't know the center yet. We don't know the radius. Okay, nothing about it. We only know that there is a point negative 3, 5. It really doesn't matter where your negative 3, 5 is. I saw that some of you have it here, some of you have it here. Okay, as long as it is on the circumference of the circle. So maybe I'll just place mine here. Okay, and I also noticed that some of you drew your tangent. Okay, something like that. Right? So we have the equation of the circle. We may want to just label it, that's fine. And then we want to find the equation of the tangent. So I place a question mark over there. Okay? So even if you draw on the diagram, at this juncture, it seems like there is no information for you to start. Okay? Then we want the equation of the tangent. Tangent, we know that it is a straight line. Straight line, what must we have? Okay. What must we have to find equation of straight line? Just I mentioned two things. Gradient and straight line. What must we need? Gradient and. Do you write down anything just now? You look lah. You look at my face, no use. Yeah. Exam also my face not there. No. find the C, okay, or we just need 1 point, right? Okay, so equation, we will need gradient, we need 1 point. Do we have the 1 point? We got it already. Okay, so the issue now is the gradient. Okay, how to get the gradient? There's no other point, so cannot use the formula. Okay, then the thing would be, just now we learned tangent perpendicular to radius. That is a very useful property whenever we deal with tangents. So we need to identify where the radius is. We don't want to randomly draw a radius in. We locate the center, draw it meaningfully towards the point that you already have. Okay? So I can label this center C lah. Okay, then after that, perpendicular. So we make use of this perpendicular concept to go towards finding the gradient. Okay, but then to know the perpendicular concept and go towards the gradient, I must know what is the gradient of the radius. So I must know what is the gradient of this. Can I find the gradient of this? At this point, maybe not, but I can do so so long as I have the gradient. I have the coordinates of the center. So if I have the coordinates of the center, I can know this gradient. I can know this gradient. Then I can solve the question. So the biggest key to solving this question is, what is the coordinates of the center? And can we find the coordinates of the center? Can, right? Because we got the equation of the circle. So long as I have equation of the circle, I can know center, I can know radius. Right? So that is the biggest and most important fact that you need to discover. Okay? So now we first find out what is the center. Where is the center? So we have let center be the point C with coordinates AB and radius be R units. Okay, I label center with the point C so that it's easier for me to label and present later on. So we go through the routine using standard form. Compare with the given equation. By comparison. We see negative 2a is 3, negative 2b is negative 2. And then a squared plus b squared minus r squared is 0. Okay. In this question, do we need the radius actually? Not necessary. Alright, so it's not necessary to know the radius. So actually, if you don't want to find and continue this one, it's also okay. Because our key was to find out the center. So a is negative 3 over 2, b is 1. So we found the center. Find the gradient of Cp. That would be 5 minus 1 over negative 3 plus 3 over 2. Or the minus negative 3 over 2. That's negative 8 over 3. And gradient of tangent will be Nicole. What's the gradient of the tangent? (3 over 8). Yes. Okay. So gradient settled point given, can find the equation now. Minus 285. So y is equals to 3 over 8x plus 49 over 8. If you like to, you can put it as 6 and 1 over 8. That's also fine. Okay. Okay, unless the question requires and asks you to leave your equation in integer coefficients, then we will multiply throughout by 8 to get an integer coefficient equation. Okay, so this is what we call integer coefficient equation, because all the coefficients are integers. Alright? I'm not sure whether you have realized, right, when it comes to this topic, the steps can be very lengthy. Okay, so there's really a lot of thinking that you need to, that's really involved. Okay, for you to think backwards, okay, think step by step, and to go and find out what exactly must you find first to unlock everything throughout. Okay, so it's like playing your escape room. You find the first key, then you can find all the other keys, right? You all play before escape room. Okay. They give you P and Q, it lies on the circle. PQ is a diameter. Okay? Because it says that it is a diameter, it is very useful in telling us that PQ passes through the center. If they did not say that PQ is a diameter, okay, even if PQ lie on the circle itself, it can always be a chord. Okay? So the important thing about PQ being a diameter helps us to understand that the diagram should look something like this. Okay, so P is negative 5, 8, Q is 1 and 2. Question wants you to find the equation. To find equation, we must have center, we must have radius, right? Will you all be able to do this question? Okay, I want you to give this a try. Give you maybe about 5 minutes to determine the equation of this circle.
Yeah. Maths people usually E-maths, E-maths. Very fast. No lah, no. First few weeks now. There's those kind of most of you are on the right track. Okay, you can find center by midpoint. Alright, then after that, find the radius. You can determine the length of CQ or the length of CP. Otherwise, you can find diameter divided by 2. Right? So, I will not go into detail, but that will be the answer. Do you all get it? Okay. Sorry. Formula of midpoint. Midpoint formula is to add the x coordinate divided by 2, y coordinate divided by 2. Okay. Think about midpoint like an average. Okay. When you study statistics, middle, right? Okay. Middle we have our mean, median, or mode. Okay. So it's an average. So when it comes to average, we take the sum of total divided by 2. So that's why midpoint formula works that way. Okay. The average. So in part 2, we want to find that you are given, okay, that the line 3x minus 5y equals 13 meets the point at Q. Meets the circle at Q. Explain why this line is the tangent.
to the circle and Q. Okay, so how would you go about trying to verify that it is a tangent? What will you think of? Zhen Quan, what do you think? For the past few questions, we have been relying only one property for tangents. Tangent perpendicular radius, right? So if I want to verify that, let's say this line over here, okay, which we have given 3x minus 5y equals 13. If I want to verify that this is going to be the tangent, it must be perpendicular to the radius. So I can derive the gradient of this. I can also find out the gradient of the radius. So even in fact, in part I, if you didn't find the center, you can still find out what is the gradient of the radius, because it will be the same as the gradient of the diameter. Okay? Okay? So we can find the gradient and then compare it with the gradient of the line. So that will be what we will do. Okay? So gradient of CQ, C would have been negative 2, 3. So 3 plus 2 over negative 2 minus 1. 5 over negative 3. And then 3x minus 5y equals to 13. Gradient of that line, because we at least up to here, we have not yet verified that it is a tangent, so we call it just a line. Okay, so don't say gradient of tangent yet, it's 3 over 5. So we see that negative 5 over 3 times 3 over 5 equals to negative 1. So since the product of the gradients and the radius CQ is negative 1. The tangent, the line is perpendicular. To the radius. Therefore, the line is a tangent to the circle and Q. When do I see you again? Even with okay, I do have one more try 10 to go, but I don't see that it is necessity for me to go through before you do your homework. So I'll continue to give you your homework first. Okay, so since you have air due on 15th January, you will have circles due. Okay, you have very strange homework that's due on 14th January. Would that be okay? So homework question 7, 11, 13, 23, 25, 26. Okay, so 6 questions, right? It may require some thinking. So long as you rely upon your tangent, perpendicular radius, and perpendicular bisector of circle, draw your diagram, you will definitely be able to do it. Okay? Yes. Oh yes, exercise 8.1. Okay? So right, because the next lesson I will only be doing one more question, then I will just write the question on the whiteboard, so no need to bring your volume A textbook anymore. Right, so next lesson onwards, after I finish try 10, right, I will want to go into volume B of your textbook. So please bring your volume B from Thursday onwards. Okay, we will start our differentiation topics.